Hello dear learners. Through this video, we will learn about the statements of the second law of thermodynamics. There are two classical statements of the second law of thermodynamics. 1. Kelvin-Planck statement, related to heat engines. 2. Clausius statement, related to refrigerators and heat pumps. Kelvin-Planck statement, given by Lord Kelvin and Max Planck. It is impossible to construct a device that operates on a cycle to receive heat from a single reservoir and do an equivalent amount of work. As you can see in figure A, we are supplying a Q1 amount of heat from the source at temperature T1 to this heat engine. This makes the engine do work W equivalent to Q1, which results in the absence of sink. Therefore, such a type of heat engine is not possible as it is violating Kelvin-Planck's statement. Whereas in figure B, similar to figure A, we are supplying Q1 amount of heat from the source at temperature T1 to the heat engine. This makes the engine do work W equivalent to Q1 minus Q2, where Q2 is the amount of heat rejected from the engine to the sink. Therefore, such a type of heat engine is possible as it is not violating the Kelvin-Planck statement. Kelvin-Planck statement can also be expressed as no heat engine can have a thermal efficiency of 100%. Clausius statement, given by Rudolf Julius Emanuel Clausius, a German physicist in 1850. It is impossible to construct a device that operates in a cycle and produces no effect other than the transfer of heat from a lower temperature body to a higher temperature body. As you can see in figure A, refrigerator R is extracting Q2 amount of heat from low temperature body at temperature T2 without doing any work to the refrigerator. This will result in the rejection of the Q1 amount heat, equivalent to Q2, to the high temperature body at temperature T1 from the refrigerator. Therefore, such a type of refrigerator is not possible as it is violating Clausius's statement. Whereas in figure B, refrigerator R is extracting Q2 amount of heat from low temperature body at temperature T2 because W amount of work done on the refrigerator. This will result in the rejection of the Q1 amount heat, equivalent to Q2 plus W, to the high temperature body at temperature T1 from the refrigerator. Therefore, such a type of refrigerator is possible as it is not violating Clausius's statement. Like any other physical law, the second law of thermodynamics is based on experimental observations. To date, no experiment has been conducted that contradicts the second law, and this should be taken as sufficient proof of its validity. Dear learners, join us by subscribing to our channel and become a part of the family.